Hi everyone. I'll give you some lecture about UnityWebRequest. So feel free to ask anything at any moment. Like pretty much, if I'm talking about something everyone knows, just tell it. So I'm not wasting time. Okay, so let's go. So UnityWebRequest is Unity API. You can use from scripting, and its purpose is to download stuff from internet. So it has like additional stuff, like it can read local files via file URI, but like it's not meant for that. And basically, if you're reading local files, it's like you have pretty much better APIs for every use case, probably. Except I think loading texture, which is the only small advantage, which is because we don't have a synchronous texture loading API. Yeah, that's about it. So like, whenever I see like people using UnityWebRequest to load local files, I always discourage them. Like, why are you using like heavyweight engine like when you have just direct file access API? Right. And another thing is that UnityWebRequest is like for one-time request to internet. Like you want to download, basically to download something, not like continuous communication, like multiplayer or something that goes on and on all the time, like back and forward communication. It's like one time. It's a replacement for dub class, like to basically remove its limitations. Okay, so I think I'll start with HTTP basics. Like in case you know, like just let me know. So I'll skip them. Basically, the basic of HTTP is like a client sends a request to server and the server responds. Like it's back and forth, and like the communication, like you can send like another request, get another response, and it's bouncing back and forward. And like it's a protocol. It has a predefined structure. Like the base structure starts as a text file, and the very end might be a binary. But the very beginning of the request is always a text file, plain text. So you have the first line of the text is basically it's called the request line or response line, well, depending on whether it's a request or response. Then you have a bunch of lines which are called headers, and you have empty line, and after that you have body, which is where the binary data can happen. Well, basically body is arbitrary data. It can be like anything. That's a basic structure, and the response looks pretty much the same, like response line, headers, empty line, and then the body. Right. So okay, so I define like what the request line is. Like it has the line itself like begins like you have one word which is called the HTTP method, and then you have an URL and optionally an HTTP version at the end. So basically, you type a line like get. Then you like the URL you want to download, and that's already the request line. And there are like a bunch of a standard HTTP method. Like get, you want to download something. Like post, like to upload something. Head is like same as get, but you don't download the body data. Well, basically, get and head are pretty much the same, except that with the get, you actually download something, and with the head, you basically check whether something exists. Basically, head returns same as get would, except the actual data. Like an example, you can think of an example like you have 2 GB image file, supposedly, like you request it with a head request, it will basically format, like return all the headers, like it tells you size of the file, the format, probably something else, but not the file itself, like so it's just fast. Then you have a pod, which is also upload something to the server, which is probably what is the difference between post and pod. It's probably easiest to understand the thinking in terms of file system. Put it like place this file there. If I do it again, like I overwrite what was there. If I do like for the same stuff multiple times, so I'm basically overwriting it over and over again. The end result is the same. With the post is not. And basically a good example of the post request, is like write a post on Facebook. If you do it 5 times, like you wrote 5 identical posts. not like overwriting the same one. Well, that's kind of the difference, that what happens when you do a post request is up to server. With a put, like, it's kind of predefined that you should be like overwriting something, like, and delete is like obvious. Again, like, it's kind of delete is also probably worth to note that it's something like ensure this doesn't exist. Like, it's not an error to delete something that doesn't exist. Yep. Okay, and also a server decides what is supported. I mean, it's not like you can send any request to any server. Like, you say, like, I don't support it. Yeah, basically get request, like when you type a URL into a browser, you hit enter, like that's what browser does, like get request. Yeah. Now what you see in a browser, again, is like a recorded body, like pre-formatted in some way. And there's like this thing called safe about HTTP request. When a request is called safe, it means like a safe request is when like it's not your fault that you damaged something on server. It's server bug, not yours. Like, basically, you type some URL like in a browser, you hit enter, like, oh, you like brought down the entire server. Like, it's their bug. Like, well, that's what safe means in this case. Okay, yeah, like I probably explained, like, yeah, already. You don't get the actual data, only the metadata part of the request. Post, well, yeah, post is like probably uploaded, like about writing like a post on Facebook, and it's not safe because like you're actually, the meaning of a post is modifying data on the server. So like you're modifying something, like, so it's kind of not safe. Well, not safe in HTTP term because you can actually destroy something. Well, you probably need to think like it's a client application, server application. Like if client application like starts sending tons of requests and damaging some data on a server, like, well, it's client bug, not server's fault. So that's what like safe and not safe means. And there's also this called term idempotent, I think it's called. Well, basically that doing the same post request multiple times, it's like every time it's a different story. Like, well, that's different from put request. Like that put request, like it's doing the same request, sending multiple times, kind of yields the same result in the end. It doesn't matter 3 or 5 times or 1. Basically, as long as it's successful, like the end result is the same. And delete is somewhat obvious. Yep. Well, if you have any questions about it, just ask. Okay, so HTTP response probably tells you the state and optionally sends the data in it. And well, we have this in a response line. We have like this response code, which basically tells us what is the result of the request. And the response code is like 3-digit number. And probably they are just categorized into groups. So like every request, like 100 is like some informational. Usually it's not a final state of the request. So in most cases, when using UnityWebRequest, you shouldn't get that because like that's some intermediate state which is handled automatically. Now 200, everything 200 is success. Well, you can look in Wikipedia the exact code. Like usually 200 is like success, and like every other like have some extra meaning to the success. Okay, 300 is for redirects. Okay, so this is again, you need to tweak UnityRequest to get those because by default UnityWebRequest handles redirects automatically. And basically you request some URL and the server responds you like, okay, everything is fine, just go to the different URL. And like means you should send the exactly same request just to different URL. So that is handled automatically. Well, you can tweak the settings to say like, I have like limit the number of redirects. So if you set limit to 1, then you would get like 300. But I think we have like, I don't remember what exact number of limit is, like 16 or something. So, well, to prevent like the cases when two URLs redirect to each other, because and not get stuck in an infinite loop. Yeah, again, like there are different types of these redirects. Like they have meaning, like permanently moved, temporarily moved, but that basically still like go to a different URL. And like there are two more groups, like 400, 500, which always means errors. So now there is like this thing in UnityWebRequest that you have two properties now, is network error and is HTTP error. Where network error means like we had unsuccessful communication at all, like wrong host, like incorrect URL, like we couldn't reach the server. Now is network error will be false if you had a successful HTTP communication. Basically, we sent a request, we got a response, it's successful communication. Now, we have other property like is HTTP error, which basically tells that from HTTP perspective, was it successful or was it an error? So like 400 class is all sorts of client errors. This is considered something wrong on your side. And 500 is like something wrong on the server side. Almost common like is 404. You know what 404 is? Yes. Basically the URL you passed is incorrect. Like basically the beginning of it is correct, but the end is not. And basically you are requesting a resource that doesn't exist. Like usually after the slash something, and something that doesn't exist on the server. And we probably know that what 500 error is. 500, exactly. Yes, it means internal server error. Just simply. Okay, so now we are going to the request itself. So like I said, it's one request only, like not continuous communication. You can't reuse UnityWebRequest. Just you have to create a new one every time you want to send a new request. Yep. Okay, now UnityWebRequest has two properties called upload handler and download handler, like to which to attach separate objects. Like, so the upload handler, you need it when you want to upload something, like something other than the headers. Basically, like I said, like in a request, you have request line, the headers. So this is like the top thing which is handled by UnityWebRequest. And then you have, when you want to send some body data, like upload image or something, you need an upload handler. And download handler is like for handling body data you receive. Without, if you do UnityWebRequest without download handler, so all you can get is basically the response code and headers. Well, fine for a header request for which you don't get any data.
So if you try to download some, like if you try to make a web request to download something and you don't attach any handlers, you're just going to get the headers?
Yes. But you'll still have to like waste all the time actually downloading data. Yep. You just download everything and discard all the bytes you have downloaded. Great decision to not attach. Okay, yeah, simple example. Yeah, I probably didn't mention that UnityWebRequest kind of has these high-level APIs and low-level APIs. Like with low level, you just create a UnityWebRequest, set up it, like attach download handler, upload handler, and so on, and like a higher-level API, just make it quicker. So here we are using like a high-level API because like this UnityWebRequest.get. What it does, basically, it attaches a download handler, or the default download handler buffer, which stores everything in memory for downloading the body data. So you would get a Unity web page here. Oh, for get requested, I think it doesn't attach any upload handler, but because we are not uploading anything. It is recommended to wrap it in using block. Usually, there are exceptions, but usually you have to, because after this block exists, you destroy UnityWebRequest and release all the resources it held. So kind of rather not to wait for a garbage collector later because you just discard it here and now. It's recommended to use the coroutines. You know how to use the coroutines? Yes, okay, so good. Because like when you yield return, send web request, you basically the next line gets executed after request is finished. Now, this is probably important thing, like always check for errors. This network is not reliable, in particular from our user bugs, which sometimes send the request to a random URL, which if a bug is like more than a half year old, like that URL might be like no longer working. And if users don't write like this any error handling, so yeah, you get like, oh, a request failed, but it failed like with a valid URL, HTTP, like not found error, and not because like something else. Yep, so if it's successful, yeah, you can like deal with it. Usually you want to deal with the data you downloaded, which you retrieve from download handler. Yep. Well, this is the lower level example, which is where we create new Unity web request. Here we like set up HTTP method we want to use, get in this case. We attach a download handler manually, and everything else is the same. Well, it kind of shows what that UnityWebRequest.get does under the hood. Okay, now we are switching to different download handler. This is download handler texture, which expects that what we download is an image file, and it will automatically create a texture for it. Now here using low-level API, so just attaching different download handler, and that's it. And all those specialized download handlers usually have a static method getContent so that you don't need like all those fancy casts, just pass UnityWebRequest to get content. In case of texture, it returns you texture. In case of asset bundle, it will give you asset bundle, like just to avoid all those castings and stuff, just to make it quicker. Yeah, I mentioned asset bundle, audio clip, movie texture, and there is one like probably kind of different download handler, which is a download handler file, which actually doesn't give you data. It downloads, it just writes everything to disk on a file. Useful for if you're downloading something very large, like so to not waste memory, just writes everything to file. Okay, and probably the fanciest download handler is the script, which allows you to write your custom C# code to handle like requests. Yep, there are like, okay, well, you just extend the download handler script and override few methods. For it, what you need to know about it, that under the hood, UnityWebRequest will cache the downloadable data and only process it once per frame. So you are running on a main loop. You don't need to worry about all the sort of threading. Like this is just like an update. You kind of like update runs like everything's safe. You can call Unity APIs. Like it's not like because UnityWebRequest itself runs like in the background on another thread, but like the download handler script runs in a Unity main thread, so you don't need to worry about all those thread safety issues. Yep. So okay. Well, the important methods to override, like receive content length, it means like when we receive headers and we know the size of the data we are downloading. Usually it will be called once, but it's not guaranteed to happen once, because there is like modern HTTP has this so-called chunked data transfer when you don't know in advance how many bytes you are downloading. So basically, it will be called, I think, every time when we kind of update the amount of data. Basically, we know in advance, like we have at least this amount of data, but it might turn out to be more than that. And I think it gets updated every time this number increases. Now, receive data receives an actual data, a byte array. The important thing here is that don't rely on the size of the array. Use this variable which tells you how many bytes you have in an array. There are a couple of reasons for that. One, probably the main reason is that download handler script accepts a byte array as an argument to constructor. You can pass, and if you pass it, that byte array will be reused every time. If you don't, then every time receive data is called, a new array is created. Well, basically creating garbage every time. So if you want better performance, not to waste memory, you probably pass a large array to the constructor, and you will get it every time here. But it will be of the size you created. And how many data actually arrived in that frame, well, this variable tells you. If I remember correctly, this received data is never called for 0 data. You always receive some data. And it has a return value. If you return true, it means you have successfully processed data. If you return false, you abort the web request. So you received some data, you return false, you say, okay, this is already wrong, let's abort it. Yep. And eventually you get called, if you don't abort the request and everything goes successfully, you get complete content, which is the last call, meaning everything is done. Yep, upload handler, this other part. Okay, this one is simple. Currently we have 2 upload handlers, raw and file. So at a low level, just upload handler raw simply takes a byte array, which is supposed to be sent as body of request. It's just as simple as that. We have APIs to construct that high level API, which constructs that byte array. At low level, just byte array, just raw bytes. You upload as a body. And upload handler file is the same, just it reads everything from file. So if you want to upload something very big, you can run into issues like memory problems on mobile devices, for example. So the solution is to write everything, the body, to the file, and then use this upload handler so it will send from disk. Yep. Okay, so high level API. Okay, I've already showed you the get. Now we have a bunch of different ones. So as you can see, a class name slightly changes. This is because we recently did modularization in Unity, so that we could remove everything that is not used. That's why UnityWebRequest itself got modularized as well, because originally it was always UnityWebRequest.these, but now we have split it up. So it depends really on the version. So be aware that on older Unity version you have UnityWebRequest.getAssetBundle. Now you have, in later version, you have that with asset bundle. And just the difference these just simply attach different download handler, but in all cases it does the get request to the server. Okay, now the post, UnityWebRequest.post does the post request. Basically configures it, because until you did the send web request, nothing is sent, you can change anything. Sorry about that. We have, okay, the post attaches the raw download handler and download handler buffer by default. And we have multiple variants for the additional arguments for the post. So you can pass string, which is expected to be an HTML form, in the web pages. Well, it's already probably in this HTML form, in this pre-formatted, format. I think it's field name, colon, and the data, and on a separate line. And it will be URL encoded for sending. Basically, if you want to send just a string to a server, simple string, better convert it to bytes yourself. Don't use this, because this one expects a form. And we have www form class, which allows you to set up like all those kind of fancy form. You can like, and again we have two more, like a list and dictionary, to send a more fancy HTML form. Like when you want like multiple section, like we are sending field, sending file, like a mixture of these things. Now probably you have filled some forms on the web, so it kind of constructs the data that it gets sent to server. Yep, and I'll put ahead and delete and somewhat self-evident. Not much talking about it. Yeah. Well, life cycle is pretty simple. Like you create a request, set up it, and then you call send web request. At this point, it's already running. Then you wait for it to complete, like consume data, and now you have an option. So you can call dispose method manually to destroy it. Well, wait for GC for it to collect. Using block just calls dispose when exits. Yep. Okay. Different ways of waiting for completion. So you can like store UnityWebRequest in a script and just check it's done properly every frame. When it's done becomes true. It becomes true when everything is finished, regardless of whether it's error or success or something. Just when it becomes true, everything is done, you can deal with the data. Yep. Other ways, like use the async operation returned by send web request. In earlier version, it was just send. But it returned async operation, and this one returns like this web request async operation. Hopefully I'm not losing my voice. Yep, so you can return it from a coroutine, in a coroutine, and the next line gets executed when it's done. Or you can attach a completion event handler to the async operation that gets called when it's done. You can mix those options together, and well, don't do a loop until it's done. Don't. It's a bad idea. Requests take a long sometimes. Particularly it's web. If it's an internet request. So, and on some platforms it doesn't. It might even not finish if you wait synchronously. Like some platforms don't handle like redirects properly if you wait, and so on. So it's a bad idea. Okay, here's an example of using async operations. That's pretty simple. Just attach dot completed and attach a method that gets called, and then extract web request and deal with it. Important when using this, don't use a using block and don't use dispose, because if you do, you will destroy web request before it completes, and it will abort. Yep. Okay, consuming data. Yep. Again, always check for errors. Data is only available when you have finished. With exception to script handler, where you have data arriving, get data from download handler, and like use these useful utilities like to convert data to proper format. Of course, the download handler must match the one attached. I think talked about disposing already. Like you prefer using block all the time. So you handle exceptions properly in C# and yep. Upload handler, download handler also are disposable objects, and the web request by default disposes them too. There are like properties like dispose download handler, dispose upload handler. You can set them to false to not dispose these. By default, they are like true. Yep, known issues. Okay, probably some of you have seen this already about chunk transfer. I think yesterday it landed to trunk already to set chunk transfer to false by default. Turns out the web is not ready for it. So it will be like backported soon, so this problem should go away, at least in the usual cases. Okay, another common problem often pops is that texture gets destroyed when you switch scene or unload unused assets. So it means basically, if you are using download handler texture, make sure everything is in the same scene. Everything in the same scene. Don't switch scenes because like you're risking like destroying texture while it's being created. Like I mean, download handler texture is designed to create texture automatically fast on the other thread, but like not to handle like these corner cases when you're like destroying things while they're being created. So if you like want to switch scene, tell the user like use download handler for buffer and just create texture from bytes. Don't use that download handler. It's not meant for that. It's about it, looks like. So if you have any questions, until I haven't lost my voice.
So when should you use the high-level API and when should you use the low-level API?
Basically, pretty much always like start from high-level API and just fall back to low-level. There's no like high-level API that creates a download handler and attaches it. So if you know it attaches the wrong one, so like just you can avoid the creation of it.
Where does the download handler store data while it's still downloading, or where is it sort of cached or something?
Mostly in memory.
Because like there was a case where a user said if you download an asset bundle while there is literally no space on the SD card, like the persistent data path.
That's a special case.
Yeah, but I was wondering, like I did tried to reproduce the issue, but I had no space on the SD card, and it's still sort of finished. I was just wondering where did it go?
Yeah, well, it's a special case. Like I mean, download handler asset bundle like creates like this asset bundle in an asset bundle system and feeds data to it. And now it's like probably a question to asset bundle people, where does it go? Like I don't know. Like I just feed data to asset bundle stream, and it's like it is decompressing. So like I think it caches internally and copies into the extracts. It's like there's all sort of it like going on. Any more questions?
Yeah, you said that we shouldn't be using download handler texture when switching scenes, right?
Yes.
And does this affect the asynchronous scenes? Like we can now have 2 and 3 scenes at the same time. Does this affect loading new scene or removing a scene?
I think yes, because like every time we do like this unload unused assets, which happens I think when you load scene and it like unloads unused assets, the texture is under risk being destroyed if it's not used in a scene. Yep. Any more? Well, I guess we're done then. Thank you.